Hello everyone, my name is Elivelton and I will present the paper an optimization approach for emergency vehicle dispatching and traffic light adjustments in response to emergency in smart cities. This paper was written by me, Daniel Costa, and Maycon. Now I will do the outline presentation. First, the introduction about the problem context. Next, I will present the context scenario. After it, the proposed approach will be presented. And next, the simulation results with our methodology will be shown. And finally, I will conclude this presentation. The adoption of sensors-based monitoring approach has opened up a range of possibilities for data recovery, distributed process, and quality evaluations in urban scenarios. Efficient management systems provide a fundamental service for modern cities, exploiting different sensing and processing technologies for the real-time handling of critical situations. Traffic jam, traffic accidents, fire outbreak, urgent patient transport, violence protests are some possibilities can be monitored by sensors. A study done in 2016 showed that approximately 40% of inhabitants of São Paulo, Brazil, spent an average of 2 hours commuting. This time sets in motion a series of critical social and economic events for these cities. The causal disorders produced a high estimated economic loss, representing about 7.5% of the city's GPD, gross domestic product. But financial disruption is not the only critical factor related to urban mobility challenges. Particular motor vehicles are responsible for emission of 60% of CO2 in the transport sector, potentially contributing to the ongoing global warming. And reducing this one is one of the main goals of the United Nations Organization by 2030. Traffic accidents is a particular problem that deserves a lot of attention in urban scenarios. According to World Health Organization, this type of accident is the 80th largest cause of death in the world in 2016. Projections show that in 2030, it will be the 10th largest cause of death worldwide. The Internet of Things paradigm, the vehicular ad hoc network, and intelligent transport system are some of various technologies that can assist in solving environmental problems. The efficient combination of these approaches can be essential to reduce or even mitigate some related urban context problems. Now we have the goals of this project. The first one was developing an algorithm for automatic assignment of emergency vehicles to incident site. When any incident happens, an emergency alert system detects, processes, and transmits this information to some operation center. So our application starts operating according to the received alert. The other goals of this work was propose a traffic light optimization approach for emergency vehicles, reduce the waiting time for emergency vehicles on the roads, and finally reduce the impact of the emergency alert event. Now I will present the context scenario. This figure represents the operation scenario of the proposed approach. As we can see, the city can be mapped by a specific risk zone with different severity levels. We have a neutral risk zone where minus occurrence can happen over time. The region with factors has a high risk of fire, impacting of its risk and relevance of the eventual issued alarms. As we can see, two events of interest happening at the same time and are detected in different zones, generating two different emergency reports. So updates reports, the respective EPU, the event process unit, receives the alarm and processes the information and transmits it to operation center. With each turn, start the automatic vehicle dispatching process. There is a center operation with the emergency vehicles are dispatching when the central system receives an emergency alarm generated by the emergency process unit. So if you have curiosity about these elements of these figures, we can see my paper to read for it. The proposed approach. In these figures is presented the logical flow of the proposed approaches. When an emergency alarm is received and properly processed, the specific vehicles are automatically assigned and dispatched to the location of the report emergency. After it, the emergency vehicle sends a message to the device on the road. It's on to start the traffic light optimization process. So, about the dispatching emergency vehicles approach, the first one is sent emergency vehicles when an emergency alarm is triggered. Due to the scope limitation and the great number of challenges to be handled in this research area, this work was considered only three major groups. There are the incidents considered on this third scope are fire incidents. It's any type of critical events that is generated or may produce fire. This is very common in cities demanding an immediate response of a fire brigade. Health emergencies are some critical situations that may put people in danger, demand the dispersing of ambulances to the affected area. And finally, policy-related incidents such as urban violence, car accidents, public disturbance, we demand the quickly actions by the policy. So, which will be usually implemented by dispersing of police cars. Well, about the optimization traffic light approach, when some type of vehicles goes onto the road, each forwards broadcast message to all road nodes, which will be other vehicles or one or more RSU. What RSU are? Roadside unit that are implemented in a VNet context. Such message presents the geolocation, the type of vehicles, whether it is on operation or not, the vehicle's route, and some metadata that are important to receivers. So this process can be seen here. About the simulation results. This paper made use of software simulation for the practical application of the proposed approach to the complexity of carrying out real experiments. These simulations were employed in a coordinated and integrated manner to carry out the experiments in the defined urban scenario. SUMO is a simulator urban mobility, is a simple road traffic simulator package. OmniNet++ is an open source network simulation environment based on discrete events that allow the modeling and experimentation of communication network. And finally, VANS is an open source simulation environment that allows the exchange between the V2V and V2I approach communications. The VANS is used to integrate the SUMO and OmniNet++ working as an interface application throughout the trace-I with Python language. The map chosen for the simulation was one of the center of the city of Campinas because the authors already had previous knowledge of how the traffic in the region worked. As can be seen, each RSU controls a traffic light. here are many traffic lights to be controlled in this road, in this city map. There are predefined roads to evaluate the proposed approach. We can see two roads, with the road starts in the right circle and ends in the green circles. We have here the road 1 and the road 2, predefined because the sumo needs to know previously the roads for simulation. The table presents the parameters and settings employed in the simulation. Two categories of vehicles were included in this scenario: passenger vehicles and emergency vehicles. We have communication, standard communication of the sumo communication standard IEEE 802.11p. The broadcast interval is the interval at which messages are sent by emergency vehicles to the other nodes of the simulation. We setting it in 2 seconds, and the warning EV emergency vehicle distance over 200 meters. It's determines the minimum distance between the EV and the RSU that will free up the flow in the traffic light optimization. This figure results, this first result showed the CO2 consumption of the emergency vehicles in the distinguished scenarios. We have here, we have there true distinguished scenario. With optimization is a blue, and without optimization is the orange color. There are the another result. This figure shows the total time spent by the vehicle, the emergency vehicle during the simulation. There is a reduction of approximately 39 seconds between the scenario with and without optimization approach. The correlation between both figures happens because the less time the vehicles is on the road, fewer CO2 is emitted. And finally, our proposed system proved to be capable of identifying an emergency alarm and quickly distributing emergency vehicles to the location of the detected emergencies. And as future works, we will explore other applications in the ITS domain, processing notice settings and real-time data. We will to implement route suggestion algorithms, and finally to explore more efficient algorithms for automatic vehicles allocation. So thank you for your attention, and I'm open to questions.